Hello everyone and welcome to the class of natural gas engineering again. Earlier we had discussed several aspects of natural gas engineering. Most of them include about conventional natural gas production. So, today's lecture is about unconventional production of natural gas. We will discuss some of the aspects of unconventional natural gas production. If we look back in the first week lecture where we discussed about the energy need and the share of natural gas in meeting the global energy need, we had discussed like country wise what is the need of energy and in that need how much percent is shared by the natural gas and how natural gas contribution is increasing over the years, and it is expected after 10-15 years it will be the second largest energy contributor. Here in these slides I am showing you in the 1975 what was the energy need. It is again in the terms of percent total need of the energy across the globe. It is mostly shared by the OECD, Organization for Economic Cooperation and Development. India, China, Middle East and rest of non-OECD are classified, and the share of global energy in terms of percentage is shown here. It is very clear the energy need is keep going from 75 to 2010, it is almost double and it is expected to increase in 2035. Whatever the energy need in 2010, it is going to increase around 1/3 more energy will be required in 2035. Meeting this energy need, we have to depend on still fossil energy source, and in the fossil energy source it is natural gas, coal and oil that significantly or predominantly contribute to meet the global energy demand. If we look in the United States, its oil and gas production, we can see in million barrel oil equivalent per day. On the y axis we can see on the x axis how the energy of the United States is going to be changed with respect to oil and gas. Here in this slide the data are compiled in a manner of conventional oil and unconventional oil, similarly conventional gas and unconventional gas. So, we can see from here the conventional gas is going to be like this. Its share was too much in 1980 and it is getting reduced, while the unconventional natural gas share is going to be increased as we are going further. So, it is very clear from this forecasted data, natural gas is going to share the energy market. Similarly, unconventional natural gas is going to dominate over the conventional natural gas production system in the future. The surge in unconventional oil and gas production has implication well beyond the United States. It is not only the United States where the natural gas both in conventional and unconventional manner going to replace other fossil energy sources or the hydrocarbon energy sources, while rest of the world is also looking towards developing the infrastructure and the facilities to have the share of natural gas to meet their own energy demand. If we look in a broader perspective of natural gas resources that comes under the category of hydrocarbon energy, we discussed the similar content in our first week lecture also. So, when we talk about conventional versus unconventional energy sources for all natural gas, oil and coal, in terms of the natural gas, it comes to shale gas, tight gas, gas hydrate, coal bed methane and other forms. Compared to conventional natural gas, these are the other resources which can be utilized to produce the natural gas. Briefly, we will discuss about some of them in today's lecture. Depends on the geological setting and the rock type rather than to the gas itself, the classification has been done. Most of them will be producing the natural gas that is dominated by the methane again, depends on the geological setting and the rock type. If we define what is tight gas, it is relatively impermeable rock which produces the gas, and mostly that rock is limestone or sandstone. The major classification for tight gas, it is produced from the rock which is having very low or impermeable structure less than 1 millidarcy. Shale gas, where the gas is trapped in fine grained sedimentary rock shell. Coal bed methane, in that coal bed methane domain, the gas is trapped, specifically it is adsorbed in the solid matrix of the coal. Another form of the unconventional natural gas is gas hydrate. It is a crystalline case like structure where the water molecules are stabilized by small gas molecules. We will discuss in little bit more detail in the further slides. Important point here is the organic matter which is considered to be underneath over the geological time scale gone through under the slow heating and high pressure condition, the organic matter got converted to first corrosion kind of the things, then bitumen, then coal, oil, and then finally natural gas. We will be discussing in little bit more detail about these unconventional source of natural gas. Total unconventional gas production in 2014 by producing countries are listed in this table. You can see coal bed methane, shale gas and tight gas are used to compile this data for US, Canada, China and other countries. India is also here at the bottom part of this table. We can see US is dominating in most of the unconventional natural gas production. That could be coal bed methane, could be shale gas or tight gas. In total, you can see the difference between US and the second one Canada is too much difference between the total production of the unconventional natural gas. The shale gas and tight gas are different than the conventional gas. In conventional gas reservoir, the large and well connected pores are there and the gas molecules those got formed over the geological time scale. They are having the well connectivity traveling from a small pore regions to a region where they are getting accumulated and from where the conventionally natural gas can be produced. While in case of the tight gas, the pores are small and poorly connected and the permeability is also low and the reservoir rock is not having enough permeability. So, the gas are just trapped in a small pockets kind of the structure. While shale gas, it is very tightly formation where the permeability is further lower, pore size is also very small and hardly connected pores. Permeability very low means the pores are not connected at all. And in both the cases when we are having the tight gas and shale gas, the gas can be liberated from this kind of the tightly formed formation by creating the fracture, and the massive fracture either using the explosive material or the hydraulic pumping can be used to create the fracture, and creating the fracture it will allow to improve the porosity as well as permeability of the domain, and from where the natural gas can be produced to a production well. It will travel from that source to production well and we can produce. If we look in terms of the gas, how it is trapped in this kind of the formation, we can see in the tight gas sense the gas is mostly the free gas, while in the gas shell it is a mixed free gas or adsorbed gas. So, the gas is adsorbed on the rock surface, while in the coal bed methane, another aspects of the natural gas production that is listed in this table also, where we are having the coal bed where the methane is just adsorbed on the surface of the coal seams from where it can be produced. The similar kind of the data again plotted here in terms of the countries, they are having the source of all conventional and unconventional natural gas production. We can see here the conventionally production of the natural gas is dominated by the Russia and then followed by the United States. In fact, Saudi Arabia is also having a good share in conventional natural gas production. While when we talk about the unconventional natural gas production, as we had seen in the last slide in the table form, we can see either it is a tight gas, shale gas or coal bed methane. This segment is dominated by the United States. We can see here the China is having shale gas higher than the United States, but altogether this part of unconventional natural gas sources is dominated by United States, China. India is not appearing in this list. It is having either unexplored region where the natural gas in the unconventional manner, either it is a gas hydrate or shale gas, are not explored at a potential level where we can say with a confidence this much amount of the unconventional natural gas is available in this kind of the domain. We can see the chart here. The tapered chart shows the quantity of the gas produced or available in different form. We can see here it is shown gas hydrate. If it can be explored economically, technically, the gas hydrate reserves is the most abundant reserve available to produce the natural gas, followed by the shale gas, followed by the coal bed methane, then the tight gas, and on top we are having the conventional. So, compared to conventional, unconventional resources to produce the natural gas are massive. So, the unconventional resources are bigger than the conventional. North America has a much bigger portion of unconventional resources. Unconventional resources will change significantly with the data available from the other countries, where the government or the agencies are still in the process of exploring the sites or the places where the unconventional source of the natural gas can be present in a potential quantity. Here in this chart or the data shown below, we can see the share of the unconventional natural gas compared to conventional in United States and Canada. We can see the data are shown for United States in the year of 2008 and 2014. Shale gas contribution has been increased almost 5 times compared to what it was in 2008. Tight gas contribution little bit low compared to 2008. Altogether, we can see the unconventional natural gas production is 52.2 BCF per day compared to conventional, that is just 17.6. So, almost 3 times unconventional natural gas is being produced compared to conventional in the United States, and similarly we can see here also for the Canada, the unconventional production is almost 2 times of the conventional production, that is just 5.5, and these data are just for 2013 and 2014. The share of tight gas is increased, shale gas is almost remain constant, coal bed is also remain constant, and conventional gas contribution reduced from 5.8 to 5.5. But in a summary, the unconventional source are producing more natural gas compared to conventional natural gas. That shows how these leading countries in the energy sector, USA and Canada, are going to use massively the unconventional production of natural gas. In this list, gas hydrates are not included. If the gas hydrate are included, the unconventional part will be too much compared to the conventional, and it is believed the gas hydrate resources are 50 times the reserve of conventional natural gas that the world is having. When we talk about 4 countries, those will need the energy more in the near future: US, Canada, China and India. In this list, we can see the use of natural gas in both conventional and unconventional manner. We can see United States in 2010, 2020 and 2035 data, the unconventional natural gas share is keep increasing in this direction. Similarly, for the India also it is increasing, and in fact it is increasing for China also, and Canada also. The share of unconventional is slightly stagnant in 2020 and the projected 2035, but compared to conventional, unconventional share is more in each country listed in this plot compared to conventional also. If we look in India's scenario, in 2006, 2010 and 2024 data are shown in this chart, that says coal, oil, gas, hydro and nuclear are considered as the energy contributor to meet the India's energy need. We can see the coal is still dominating, oil will be second largest, but when we look the gas data, we see compared to 2024, it is expected that the share of natural gas will increase tremendously compared to other source of the energy those are being used. This is in terms of the percent we are having. So, the natural gas will be sharing 20% energy need of the country, that is just 14% in the year of 2010. When we see the energy demand and supply for the country, we can see in 2001, 2006, 2011 and 2024 data are compiled here, and the need is increasing as well as the supply and demand both are increasing. So, the supply demand plot says both are increasing year by year, and it is expected in 2024 the supply and demand will be having the 260 number for the supply. Thus, unlocking the domestic unconventional gas potential could help India meet its growing energy demand. We had seen in the previous slide the position of India in one of the chart is missing. The primary reason is the exploration or finding the site for India is not that significant, and if we can explore the site from where the unconventional natural gas can be produced, it will help India to meet its growing energy demand. However, it needs to be developed profitably and in an environmental acceptable manner. Those are the regulations from the environmental side as well as the technology that is going to be used to recover the natural gas from the unconventional sources, either it is a coal bed methane, shale gas, tight gas, gas hydrate, it must be economical. Significant sources of unconventional gas can be achieved from all these unconventional sources, and they can play an important role in bridging the shortfall that is appearing here in the chart. Currently, India is exploiting only 52% of its coal bed methane resources and 20% of its shale gas resources. Tight gas and shale gas hydrates are yet to find a place in the country's energy basket. These data are collected from 2011 Energy Outlook book, as well as some of the data are collected from the information published by DGH, Director General of Hydrocarbon India. The unconventional sources in India, the major sites for the shale are in Cambay Basin, Krishna Godavari Basin, Kaveri Basin, Damodar Basin, Assam and Indo-Gangetic Basin. Some of the places the resources are quantified. For example, Cambay Basin, it is 20 trillion cubic foot, 27 in the Krishna Godavari, 9 in the Kaveri and 7 in the Damodar, while for the others the quantification is not reported. Similar, there might be some other sites where the possibility of shale should be included. When we talk about the coal bed methane, the coal sites are distributed across various states in India. It is in Jharkhand, Madhya Pradesh, Rajasthan, where the area is more than 2500 square kilometer, that is designated as coal site, from where the natural gas can be produced using the coal bed methane extraction technique. So, let us discuss about this term, those we just discussed about the unconventional natural gas production sources. Those could be gas hydrate, shale gas, tight gas, coal bed methane, and another one is pyrolysis or thermal treatment of carbonaceous solid material. The first one is gas hydrate. So, the gas hydrates are crystalline case like structure. The case is water molecules stabilized by small gas molecules trapped in the cavities under high pressure and low temperature conditions. Most commonly, the small gas molecules are light hydrocarbons like methane, ethane, propane and other inorganic gases present in the natural gas or present in the site. Those could be H2S, CO2 and N2. Natural gas hydrates are formed when the natural gas is going to meet two conditions. First one is it is having the presence of the liquid water. Second one is the system is at low temperature and high pressure condition. This chart shows here under what temperature and pressure the hydrate will get formed. It will also depend on the composition of the natural gas. In the terms of gravity, it is shown here, like if it is a pure methane, very high pressure and low temperature is required to form the gas hydrate. But as we are seeing here, the gas gravity is increasing 0.6, 0.7 and further, even at a low pressure relative to methane, the hydrates or the gas hydrates will get formed at a low temperature conditions. In this type of the arrangement, what happens? The water molecules are going to surround a gas molecules and going to create a case like of the structure, and this phenomena happens well before the freezing point of the water and the solid kind of the or ice like structure beget. Those are less dense than the ice, and number of molecules those are going to surround one gas molecules. That gas could be either the methane, could be higher hydrocarbon or could be inorganic gases, are characterized by a number called hydrate number. But there is no fixed number for a particular gas molecules. For example, methane, here the structure is shown, one methane molecule is surrounded by 7 water molecules, but it may vary. Most commonly it is 6 water molecules those surround one methane molecules. Ethane, it is shown 8, propane 18 and carbon dioxide 7, but there is no specific structure. The structures are classified in two parts, structure 1 and structure 2. Structure 1 is formed by smaller molecules such as methane, ethane, hydrogen sulfide. In structure 2, it is mostly formed by bigger molecules like the propane and isobutane. As gas or the natural gas is a mixture of all these sort of the gases. So, the both structure 1 and structure 2 are present when we are talking about the hydrates forms with the natural gas. So, whenever the natural gas is going to meet this low temperature and low pressure conditions, gas hydrate will get formed. They can be formed in the sedimentary region, they can be formed in the oceanic region also. So, the gas hydrates are going to form whenever the gas is having water molecules and it is going to hit high pressure and low temperature region, and that has happened. We had seen in our previous classes where we had discussed the choke performance relationship, where the sudden change in the pressure and temperature because of the choke device, the possibility of the hydrate formation is there, and it is very much required to understand what level the temperature is going to be changed when the fluid is passing through the choke and avoiding the formation of the hydrate. The hydrate may get formed when the natural gas is transporting through a pipeline and the natural gas pipeline is passing through the region where the low temperature and high pressure is present. That is why it is required to dehydrate the natural gas before it is going through the pipeline system. So, the case like structure formed because of the hydrate formation can be broken to get the hydrocarbon molecules liberated out, and that can be done by depressurizing the system. Ultimate aim is changing this condition where the hydrates are getting formed. It means the low temperature and the high pressure system. So, the mechanism that can be used will release the hydrocarbon and non-hydrocarbon gas molecules out of this case like structure. It could be done by thermal injection. So, we are injecting hot brine or gas in the formation zone where the gas hydrates are formed. Because of the change in the temperature, the condition of the hydrate formation will get changed and the gas molecules will come out of this case structure and we will get the gas out at the production site. Or it could be done by injecting some inhibitor, some chemicals, those are going to change the conditions of gas hydrate formation domain, and because of that changes the gas molecules will get come out from this case structure. So, by any of this mean or other means also, the gas trapped in the gas hydrates can be produced, and if it is producing in a significant quantity, it can be used as the energy source. Other things, those affect the formation of the gas hydrate as well as the liberation of the gas hydrate are the high velocity of the agitation when we are talking about the pipeline system, presence of seed crystal of hydrates if they are already there, because the first step is water molecules there and then second is crystallization happen, because of that the gas hydrates got formed. So, if the seed crystal of hydrate is already present, the possibility of gas hydrate will be high, and presence of highly soluble gas in water such as H2S and CO2, they will form the gas hydrate easily. Another source of unconventional source is coal bed methane. In this type of the arrangement, the gas is trapped in coal seams in the adsorption mode on the solid matrix of the coal. So, the knowledge of methane occurring with coal bed is as old as coal mining. So, from the beginning of the coal uses, the gas associated with the coal was experienced and it was also named as town gas, syngas or other. So, numerous disasters in underground mines occurred due to methane explosion, and that is why when the coal was mined, it was an usual practice or a conventional practice to let the gas released before the coal is getting mined to the surface. Conventional method was just the ventilation of the natural gas. Pure methane is produced from the coal bed methane, because it is just a methane molecules or very light hydrocarbon molecules, those are adsorbed on the surface of the coals, and these methane molecules are having more energy compared to conventional natural gas, which is having some inorganic gases also present along with the methane gas, and that is where the energy content is less than what we get the methane from the coal bed seams. Large quantity of methane, it is 3 times at the same pressure and same depth. If we are comparing the amount of the natural gas that is present in a conventional reservoir or in a coal, if we compare at the same pressure and at the same depth, the quantity of the natural gas is 3 times in the coal bed seams compared to conventional natural gas reserve, and this is because the natural gas is present in the coal seams is produced in 2 manners: thermogenic coal bed methane process or the biogenic coal bed methane process. Thermogenic coal bed methane process is simply over the geological time scale, the natural gas got produced by the conversion of organic material to methane. In biogenic, it is because of the biological activities over the time the methane gas got produced. In both the manners, either the thermogenic or biogenic, the produced methane is either going to get diffused in the surrounding area, that could be the upper layer or the underneath layer, or it is going to be absorbed in a small pores, those are present in the coal seams. Because of these small micro pores present in the coal seams, the surface area of the coal seams is larger compared to the conventional reservoir, and the amount of the natural gas that can be stored in this coal seams is higher, and that is come out as a almost 3 times methane can be stored or is present in those coal seams. The factors those affect the recovery of this coal bed methane from this coal seams are the porosity, adsorption capacity of the coal seams, fracture permeability, how much fracture is available, because the natural gas those are trapped in this microporous, we need to take it out from the microporous to some clads, and from here it is travelling all the way to wellbore. The important factor those are going to affect the adsorption capacity or the amount of the methane adsorbed on the coal bed. So, these factors are coal density, the rank of the coal, pressure difference and the thickness of formation. So, at what depth the coal seams is there and how much pressure is there, what is the pressure difference between the production well and the coal seams, what is the quality of this coal, because for example, the biogenic coal bed methane is produced in a low rank system, and the quality or the rank of the coal also one of the factor that decides the amount of the methane adsorbed on the surface, similar times the amount of the methane that can be recovered from this coal bed methane. So, these factors are going to affect are listed here. We can see the process how it happens. So, the desorption of the gas from the coal surface inside the microporous. So, the pressure desaturation should be done in such a manner the gas is coming out from these micropores, diffusion of the gas through the microporous is happening, and because of the Darcy law from this porous permeable region through the fracture and cleats the gas is travelling to wellbore. Here it is shown in this systematic manner, stage 1, stage 2 and stage 3, all 3 are listed here. The stage 1 is kind of the structure here where the gas is in this microporous domain of the coal seams. When we are creating the pressure difference, what will happen? The water and gas will get produced from these coal seams. We can collect the gas from here, water from the other source, and this can be done by just creating some pressure difference in the coal seams that allows the gas adsorbed on the surface to get liberated. The recovery rate is low and unpredictable because the gas is deposited or stored or adsorbed in those microporous, and the recovery compared to the conventional is low. Unconventional production of natural gas can also be achieved by thermal treatment of some natural material or the waste. Those are also called carbonaceous material, and the technology comes under energy conversion technology, where the feedstock that could be the oil shell, coal, biomass, waste or any other like the plastics or other things, those are having the hydrogen and carbon combination. And when we are doing the thermal treatment of these feedstock, the products are fuel, oil, gases and chemicals. So, it does not matter whatever the feedstock we are having or whatever the process of thermal treatment we are adopting, the gas will also get produced, and that gas can be used or can be considered as a natural gas, depends on the composition, the purification is required or not. In most of such kind of the processes where we are having this thermal treatment of carbonaceous material, the produced gas is locally used to meet the energy need. And to understand this process, several aspects should be understood. What is the conversion of this feedstock to particular targeted product, efficiency of the process is upgrading or required or not, that is mostly required for the oil or chemical, those are getting produced from this thermal treatment process, and several other aspects. We can distinguish this feedstock like the oil shale and coal and others depend on the composition. So, the oil shale is a material where the kerosene is the organic material and rest is mineral content, those are not going to contribute to produce the hydrocarbon gases. So, the oil shale which is just contain 10 to 15% kerosene, that kerosene under the heating condition got converted into bitumen and then it goes to product, that product could be oil, gas and char. Coal is different than the oil shale because coal is having more organic content than the oil shale. Coal is almost having 80% or more than 80% organic content. Further, the coal is classified in several subcategory like the anthracite, bituminous, subbituminous coal. Biomass is a material that is having cellulose, hemicellulose and lignin constituent. Waste plastic, that is mostly made of the organic material, and when we are doing the thermal treatment, oil shale will reject lot of solid material, coal relatively less, while biomass and plastic will not. Biomass will also give some solid material, but waste plastic will end up mostly getting converted into gas or the oil substance. So, the thermal process that is going to use this feedstock material to convert into product depends on several factors. We can take the example of oil shale to understand some of the aspects of pyrolysis of carbonaceous material. So, what is oil shale? It is an organic matter which contain 10 to 12% kerosene, again depends on the origin or geological setting. The percent of organic matter and mineral content may vary. A small amount of free and bound water is also present along with this. The picture shown here is a massive deposit of oil shale type of the rock in the United States. If we see on this chart, United States is dominating the percent of oil shale compared to rest of the world. The percent or the quantity in the United States is massive. From this type of the rock which is having the organic material kerosene, actually the organic material kerosene present in this is a premature hydrocarbon, and when we heat this kerosene, it got converted to bituminous type of the substance, and further pyrolyzing or heating it, it gets converted into oil, gas and solid material. That solid material is called the char. So, the thermal treatment could be done by the pyrolysis, combustion and others. Synthetic crude oil, liquid, gases and residual solid are the product. This is temperature and time history. Over the time, less temperature is required to get converted this kerosene into the gas, liquid and solid substance. So, that is actually happen over the geological time scale. The kerosene substance got converted into several fraction of fossil energy like oil, gas and coal. Depending on the location and geological time scale, the organic material was exposed. If we can heat that organic material at a higher temperature, less time is required to convert the organic material into oil, gas and char, and that is the oil shale process, or that is the utilization of oil shale to produce the liquid substance or petroleum like liquid substance. Bituminous goes to oil, gas and char, and gas is a byproduct of this process. that can either be used as a natural gas for other sources or it can be internally used as a source of energy. Oil shale resources and importance are shown in several literature, where it is also considered that the United States is going to meet its energy need by producing the oil from oil shale. When we talk about the process or the oil shale pyrolysis process, so the oil shale is going to result in the shale oil, gases and spent cell when it is heated depends on several factors like the porosity and permeability present in the sample, the organic material and inorganic material of the oil shale or the raw oil shale. So, the oil shale retorting under high temperature and high pressure can be performed. Compositional analysis will give us the amount of the oil and gas and the type of the oil and gas it is going to produce. Several factors influence any pyrolysis process. Those could be the heat transfer, reaction, multi-phase, phase change, the mineral alteration interaction happening in the system and physical properties changes as the material is exposed to high temperature, high pressure condition. That will be the case of oil shale, coal, biomass, waste plastic and any other carbonaceous material, where the system that is getting heated going to produce oil and gas and multi-phase flow will happen in the process. For specifically for oil shale, several industrial processes are developed by big giant companies like the Shell developed the ICP process, in situ conversion process, ExxonMobil developed electrofrac process, AMSO developed conduction, convection and reflux process, and a REIT lab and a company called Red Leaf developed eco shale process. In this eco shale process, the oil shale is mined and ex situ pyrolysis was performed. Another difference in the biomass and waste plastic pyrolysis compared to oil shale and coal pyrolysis, the oil shale and coal can be pyrolyzed or thermally treated in both in situ and ex situ condition. So, some of the processes listed here are in situ process, some are ex situ. Like these three processes are in situ process, where the oil shale material is thermally treated at its original point, while in the red leaf eco shale process the material is mined to ground and a large capsule kind of the structure was established, where the material or the oil shale is heated to get the oil and gas production. Several reactions happens, those are listed here. So, when the material is heated, the corrosion goes to heavy oil, light oil, gas, char and methane. So, the classification of the oil is done in heavy oil and light oil. Similarly, the gas is classified in two part, gas and methane gas separately, and the char is a product. The product of the first reaction can go to the second reaction can go to further reaction, and it is shown here if the material, that is corrosion, is thermally treated, that can be done either considering the thermal treatment from the outside or from the inside. So, the heat is propagating in both the types, heat is propagating in a different manner and the quality of the product going to be different because of this second reaction network system. In the first case, the gas or the product of the primary reaction are going to face different path compared to this second type of the arrangement they are going to face. And the picture shown here clearly shows how the products are going to be different in terms of quality and quantity when we are choosing a particular process to thermally treat the carbonaceous material. It depends on reactor configuration, depend on the raw material, depend on the operating condition, ultimately what we are going to get. If the material is left in the heated zone for a longer time, the ultimate fate will be gas and coke. That is why it is very important to optimize the process condition of the thermal treatment, where the targeted product, that could be the oil, could be gas, is achieved and we are getting the desired product. In this type of the thermal treatment process, heat transfer happens, the species transport happens and the reaction happens simultaneously. So, all these processes are happened. Because of this reaction network chosen for the Y cell, different compounds got formed. Those compounds traveled the multi-phase manner flow and gets produced out of this heated zone. Depend on the heating system is chosen or the scheme for the heating system is chosen, or other way the configuration of the system is chosen, the quality and quantity of the product will be different. But we can get significant amount of the gas, that is methane, from such kind of the process, and that can be also utilized. Other sources of the natural gas like the biogas, Mars gas are not discussed. In conclusion of unconventional natural gas production, this slide, which is taken from some sources, says the volume of shale gas and shale oil resources of the world is massive. Advance in economically viable sustainable extraction technology would enable these resources to provide a platform for a new age of hydrocarbons, both oil and gas. And when we talk about the shale gas, is present in various parts of the globe, and if it can be economically and environmentally exploited, we are going to have a massive reserves of the gas. Similarly, for the gas hydrate also a massive reserve is available, and in future unconventional natural gas resources are going to contribute significantly to meet the energy of the world. Thank you very much for watching the video.